So I want to start by saying that this probably isn't going to be a typical write-up kind of video for the Intigriti challenge. The idea was that when I was doing the challenge, I basically just made a huge notepad document full of all of my ideas, every approach I was trying to take, so that I could kind of see my story from beginning to end, all the things I tried, all the things that I was thinking of as I was going through, so that then I can kind of recall those at the end and kind of see how I got from not knowing anything about the application to finally being able to exploit it and achieve XSS. So we need to understand the basic functionality of the page. So really it's just this calculator part at the bottom here. So it just takes two different numbers and an operator and gives you the output, right? Just as you would expect. But the interesting part is that this can also be done via the URL with different parameters. So num1 operator and num2. So this is where we're going to be spending most of our time, is messing around with this data and seeing if we can get this to somehow result in XSS. Now we need to start familiarizing ourselves with the code a little bit. So this is really where everything starts, is the onload handler for the window. So as soon as we load in, we start running this init function. Everything else after this is not really part of the challenge. It just sets up a bunch of listeners for the buttons and things like that. So we want to start our journey inside of init. So init basically just calls calc, but it calls it with three different parameters, and it gets the value of those parameters by sending num1, num2, and the operator to getQueryVariable. And getQueryVariable is basically just a function that's going to take the name of the parameter that they want to get the value of, and then try and return the value. So once our init function has managed to get all of the values for num1, num2, and the operator, it then sends all three of those values to calc. So calc is where things start to get interesting. We take the value of all three of those parameters in the URL and pass them into calc. Calc will then do a bunch of validation on all of those things to make sure we're not trying to do anything fishy, and then passes those to eval. So if we just do this manually, we can just see that num1 is equal to 5. The operator is %2b, which is just the encoded character for the plus. And then num2 is equal to 6. And so as we can see, we're already in a JavaScript context, so that runs and returns us the value of 11. But what the code is doing is putting this into eval, so that we can then take that as a string and execute that, and we get 11. So now we can make a few observations about what we've seen. We have a very, very broad overview of the code, but already there are things that kind of stand out. So the first interesting thing to me was the use of var being used massively all over the place. It's not used everywhere. We do have a const here, but var is a very old way of doing things, and it's basically inferior to const and let. And the next interesting thing is when we try to call the getQueryVariable function. It's doing some really weird way of passing things out. It's taking the entire URL, it's finding the first question mark, and then it's cutting out everything until the end of the string. And then it goes through and it splits it all by the and symbol, and then again it runs through all of those pairs and then tries to split them out into the key and the value, or pair 0 and pair 1 as they've called it here, by splitting out on the equal sign. Another weird thing about this function is that we are manually setting a global variable, attaching it to the window object. Since we're inside of a function here, this would normally be locally scoped to that function, but they've specifically decided that search query string needs to be a global variable and attach it to the window object. Also, if we scroll way down past where we're supposed to, we can see a few other interesting things like window.history.pushState, but I generally looked into those things, and firstly, they're not really intended to be part of the solution, and secondly, they seem not to be useful anyway. Another thing to note is that the regex and the index of check here to validate our inputs looks really, really tight. So for the operators, we are just given an array of different operators, and basically it's just checking and making sure that you could only pass in as this operator variable one of these 5 values. If anything else was passed in, that would fail and it would throw an error, invalid operator. And the same thing applies to the 2 regex here for number 1 and number 2. There's really no easy way to get around that. We're just going to have to work within the limits of what regex gives us rather than trying to bypass this. And the final thing I noticed about this was the obvious big eval at the end here. Basically, if we could pass any string into this eval function, then we could get that to execute as JavaScript, which is pretty much the whole goal of XSS, is to run our own JavaScript. So I looked through the entire script and tried to find any other kind of code sync that I could put my input into and have that be executed as JavaScript in some way. But it seemed eval was the only way that I could find that we could run any kind of JavaScript. So now we have a good idea of things to kind of be looking out for as we go along. We can kind of start to see if we can build a payload out of this. And we already know that eval is going to be the place that we have to get our input to, and we're going to have to get something meaningful to eval. So I generally want to start working backwards from eval and see if I can get anything in there of any use to us. So starting backwards, I want to ignore this length check for now, because for now I think we just want to get something that would be meaningful with the limited characters that we have, and then we can try and look at potentially making it shorter. So the 3 inputs are validated in these 2 if conditions. So the first one just checks and makes sure that we absolutely can only pass in one of these 5 values as an operator. And the check for the regex against the num1 and num2 variables, those are basically just checking to make sure that we only have alphanumerical characters going in. So the key part into figuring out what we can pass in is really to look at the operators, because we already know that the only characters that can go into num1 and num2 are basically just 0 to 9 and A to Z. It's really nothing interesting. Whereas in the operators, we have the ability to run, well, basically different operations in JavaScript. So of these 5 operators, the most useful one to me looks to be the equal sign, because we can start assigning values to other values, and that could be potentially useful. If we could maybe redefine a particular function call to maybe an eval function, then when that function call get called, then it would call the eval function with that parameter, and potentially we could get XSS through that way. But what I found to be most useful with this operator was the fact that we could assign a variable to the location variable. So window.location, when that is set to any string, it will send the browser to that new URL. Now that also includes a JavaScript URI. So if we're able to send a string of a JavaScript URI and a JavaScript payload over to the location variable, then we could potentially run our JavaScript that way. So first, let's just test it out locally. So we could just do location equals, and now if we put any kind of URL here, it would send the browser there. But we don't want to do that. We want to run a JavaScript URI. And let's just say for the sake of this that we alert 1. So now we need to get this exact string, as it's seen here, into the eval function. But the problem is there are characters here that we don't have access to because of the regex restraints. So the quotes here and the colon and the parentheses, we can't include those in our payload. So again, let's just open up so that we can try and see exactly what the script will see. So here we open eval, and this string is going to be what we can pass in. So if this were a normal operation that we would do, it would be like num1 is 5 and num2 is 5, and the operator will be the plus icon, and then that gets evaled into 10. So if we wanted to try and do location equals, and now we don't have access to any special characters. If we gave it anything, let's say A, then it will give us A is not defined, because we're not passing that in as a string, we're passing it in as a direct reference to A. So my first thought now is, where can I put this string, this JavaScript URI payload, where we could then retrieve it using a variable? We need to get some sort of global variable that we have control over, so that when we do location equals and then the name of that variable is equal to the value of the JavaScript payload. So my first thought was to use window.name, but you can see that this is already patched out in the first line. Now there's a small trick you can do where you set window.name on a different web page, and then when you move over to your new web page, the value still persists. But as you can see, they've already blocked that out, so it's not an option. So now I want to see what variables do I have access to. Maybe there's some other anomaly that I'm able to set a value to that we could then retrieve later on that isn't window.name. So I wrote a small script that would run through the entire window object and check anything where the key of that object, it has a value which is a string. Now it's important to remember that we only have access to things that are on the surface level of the window object. We can't use dot, so we can't access like window.location dot something else. We don't have that ability. We can only do things that are on the global window object and are strings. So this is our output. We could give a name, status, origin, default status, and search query string. Now we already know we can't use name, and I looked into pretty much all of these and I couldn't find any way to abuse them. They seem not to be ways that we would be able to set ourselves. But search query string, we did know earlier, is being set globally. So maybe we could use this to set our own payload. So if we look at how search query string gets set, this is the horrible parsing that we also noted we may be able to take advantage of. So it just checks the entire URL and checks for a question mark in that URL and then cuts everything off before that question mark, including the question mark, and leaves us with just the value. So if we ran the exact same thing, let's put some values inside. So let's just do 5 plus 6, and then we will run the same thing that they're doing. And so we can see that it cuts off everything after that question mark, and the value of this particular variable, search query string, is set to all of our input here. And so now we can play around with eval again and see if we can put something in here that when assigned to location would at least give us some sort of JavaScript execution. So if we open up eval just like the script would do, and we do just what the script is going to do, which is location equals, and then we say, okay, we want to use search query string, then we can see that it's running it correctly. So if we go back and we set the same thing again, then we can run location equals search query string, but this time we can think about what kind of data we want here to result in something more useful. So because of the way that this function parses out everything manually, it doesn't really matter what we have before these parameters. This script will just ignore any kind of junk data that it gets. So we can just put our JavaScript URI in here, and let's just say alert1, and then we'll comment out the rest of it so that when this gets into a JavaScript context, this stuff doesn't get actually manually executed. It's going to be commented out. So if we set that as our payload, everything is able to still run fine. But then when we hit our eval, we now manage to execute JavaScript. And so great, at this point we should have JavaScript execution, right? Because we already know that num1 needs to be the value of location, and we already know that num2 needs to be the value of search query string, and then we set the operator to be %3d, which is the equal sign. So now we're saying location equals search query string, and then search query string will be the value of this entire JavaScript URI, and because we comment out the rest, we're basically just running this, and that should be it, right? We should be good to go. We also need to put an and sign here to make sure that when we pass it later on, it doesn't get confused. So if we run this, we should get JavaScript execution, right? But one problem. So we can't execute this because we are now getting hit by the thing that we've avoided this whole time, which is the operation length. Basically, we're just using too many characters here. Location equals search query string, that's 26 characters long, and that's 6 characters too many. So we're not able to run this. We need something shorter. So I tried for hours at this point to try and get this shorter, seeing if I could get any other kind of global variable that I could put my data into, trying lots of different ways to try and get this shorter. But unfortunately, I could never get it below 20 characters. So my only option really was to try and redefine search query string into something shorter, because it's just way too long for us. We can't fit it in here. But if we were able to execute twice, then we could run our first time saying that A is equal to search query string, and then when we run through our location, we could just set location equals to A, and then we would have two different payloads that are below 20 characters to eventually allow us to run what we want. But in order to achieve this, we need two things. One, we need to be able to run the entire operation more than one time. So we need to be able to run it once in order to set the value of A, and then another time to call that value and set that to location. And the other thing is that not only do we need to be able to run it twice, but between each run, we need to change the value of num1 and num2. They can't be the same value, otherwise we're just going to assign A twice and never assign it to location. So the first problem of running the operation multiple times is not really too much of a problem, because there is the clear button, and the clear button will run init after that. And we can bypass all of the deletion that it does by sticking all of our parameters after a hash where this can't actually get to it and delete those, but where the parser would still be able to pass that data out and set the values correctly when we get into get query variable. But this would require interaction between the two operations, and that's not really ideal. Also, on the Intigriti challenge itself, it says that there's an expert mode, that you can do this without any user interaction. And in some ways, this is actually a blessing for us, because now we know that there's no user interaction. We can look through the entire script and realize that without user interaction, there's not going to be any feasible way that we would be able to change this URL in any meaningful way between operations. And so that helps me to really think outside of the script and think, actually, we could achieve this without user interaction, without using any of the script on this page. And so by looking through the code and realizing that there's no way we can trick the script into changing our URL in any meaningful way, that brings me to a way that we could force the URL to change ourselves, and that is to embed in an iframe. Now the thing is, there's not much interaction we can actually do with this iframe because of cross-origin. This is a completely different website. We can't just start touching that through our iframe because, that would lead to very, very bad things. So we need to figure out what things can we control on our page that will have an effect on the embedded iframes page. And so the key thing that we have access to change is the URL of the iframe. So we can change that value, which is exactly what we need. We need to be able to change that value. So one thing we need to be aware of is that every time we change the URL of the iframe, it's going to cause a refresh to the page. And that's not what we want, because we want it to run through multiple executions in that eval function, but also allowing us to keep the results of what that gave us. So if we ran our first thing to say that A is equal to search query string, well, we need that to stay so that the next time that we run location equals A is still equal to search query string. Now the thing is, we can easily get around this by just making sure that everything that needs to change exists after the hash, because the hash is only designed to be used for the client. So if we change this to DDD, you'll see my web browser doesn't make any attempt to reload the web page. We can change this to any other value we want. It won't try to do that. But if we were to add any kind of extra thing on here, even if it's just a URL parameter, if I hit go now, then it will refresh that page. But we already know that the parser can easily look past the hash icon, and we can make all of our changes to num1 and num2 here, and the parser can still go and get that information and treat it as if they were actual URL parameters, despite the fact that they exist after the hash. So now we know how we're going to run data 2 different times. We're going to simply set the URL to one specific payload in the first instance, which is going to be A equals to our search query string, and we're going to make sure that everything before the hash stays exactly the same as what we're going to run the second time. So now that A is equal to search query string, now we can run location equals A with our second one. We just need to set that a second time. So if we click run here, we can run through. So the first time here, it's got set to A equals search query string. And then after 1 second, we just want to let it have time to run everything before we try and change the URL. Then it changes to the second one, which is going to be to set location equal to A. Now the problem is this isn't going to run until we call init. Now we already know, as I mentioned, we can always call init with the clear button. So if we click the clear button, there we go. We have user interaction XSS on the page. So this would still get you a win because this is valid, right? We are now running the JavaScript that we want on that iframe inside of it. So we basically completed the challenge, but there is an expert mode to see if we can get this going without any kind of user interaction. So if we go back to the original code, we can look through and see, okay, well, at what points does init get called, right? There are many points when init gets called, but the interesting one to us is when the page loads, right? So we have this window.onload equals, and then we're passing it a function, right? So that's all we're doing. We're setting a variable equal to, and then we're passing it a function. And then every time this event gets called, which is onload, this function is going to run. So we can do the exact same thing for our code, except we can set up a different handler, whatever handler we want, and then we can pass it a different function. In our case, we want to call init to make sure that it all runs the entire thing all over again every time that handler fires. So I looked through all of the event handlers that I could on the global object, and there was one that was extremely useful to us, and that is the onHash change. So every time the hash changes, this new event gets called, and it will call whatever function you assign to it. So in this case, we just set up on our first iteration, we want to run the command onHashChange equals init. And then that way, every time the hash changes, it's going to call init. But now if we run this, it won't work, right? Because we've now replaced the piece of code that says that A is equal to search query string. So we now need to have 3 iterations. The first time to get hit by the onload handler when it calls init, and that will set us up so that every time the hash changes, it will call init. Then we can go ahead and do our first iteration where we change the hash 1 time, and we're going to change that so that A is equal to search query string. And then once that changes, it should run init because we set up this handler, and then we can change it again for a final time, and this time set location equal to A. So here is our final payload. That's exactly what we're doing. We set onHashChange equal to init so that it runs every time the hash changes. It's going to rerun all of the data from num1 and num2. And then we're going to set it so that we will set num1 equal to A, so that A equals search query string. And then we're going to come through and set location equal to A, which will be our search query string with our hidden JavaScript URI inside of it. So if we run this, now it should be totally interactiveness. There you go. After 3 seconds, both of them have executed. I just add that so we have enough time, but you could probably shorten that a lot. And we just have XSS without anyone touching anything. So that was the end of the challenge. And I absolutely love doing these. I'm really happy whenever they release a new one, and I will probably continue to do them. So yeah, I really, really appreciate Intigriti giving everyone the opportunity to do this. And I can't wait for another one.